Alright guys, welcome to your Semester 2 practice. Today we're going to be talking about the quadratic formula and the discriminant. So we'll be defining this discriminant, something you hopefully have seen already. We'll use the discriminant to find some interesting things about graphs and zeros, and then we'll find the zeros using the quadratic formula. So this should feel like what you're doing in your algebra class, just a little bit more background, a little bit more practice. So to talk about the discriminant, we first have to talk about the quadratic formula. Quick sidebar, the way I learned this, and maybe this will help you remember how to write it down, you sing it, of course, to the tune of Pop Goes the Weasel. So if you'll bear with me, the way I remember it is in my head, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now you pause, you try it. Great singing, great singing. The discriminant portion of this really important formula is this part shown in red here. And what's cool about the discriminant is it's going to show us what our formula is going to do, or what our quadratic equation is going to do. So I'll show you an example of that here in just a moment. So the discriminant tells you how many zeros there are for your original quadratic equation. So we're going to take the discriminant. In a second, we'll show you how to plug this in. But if you end up with getting 0, if this b squared minus 4ac business, if it ends up equaling 0, you end up getting one solution. That means that your graph would touch the x-axis in exactly one place. So that's what you can see here. This is just an example one that I made up, but it crosses exactly once at -2, 0. Okay, so that's an example where if you get 0, this is the type of graph we're going to see. Next, if you get a positive number out, which is sort of maybe the most common type of quadratic that you will see, you'll get something like this. It will cross in exactly two places. So you have -5, 0, and 2, 0. Those are the zeros, or the solutions to our quadratic if you get two solutions, right? And kind of weirdly, sometimes b squared minus 4ac will come out negative. That means that there are no real zeros. That means that our graph, like this one, never crosses the x-axis. So hopefully that makes a little bit of sense. Connects it to the graphing that you've been doing in your class. Okay? So let's do an example. Here's one where we're going to get the 0 solutions. So that means if we look back up here, we get no zeros when it's a negative number, the discriminant. So we're going to anticipate that our discriminant is going to be negative. Let's see if that's the case. Okay, so we'll start with this quadratic. 2x squared minus 7x plus 12 equals 0. Conveniently already in same form. So if we find a, b, and c, which is 2, -7, and 12 respectively, we plug that into our discriminant, b squared minus 4ac. So we get b squared, that's -7 squared, minus 4 times a, which is 2, times c, which is 12. To do the arithmetic there, we get this becomes 49, and if you multiply all of that together, we get -96. And we subtract 49 minus 96, you get -47. Remember, if we get a negative number, that means that there are 0 solutions. That's our fundamental expression. It doesn't cross the x-axis at all, something like this. Okay? Alright, next, we are going to do one and we end up getting exactly one solution. Okay? So on this one, we have x squared plus 4x equals 4, which is 0. Here, there's no a written. We know that that's an implied 1. C is 4, and c is also 4. So simply plugging those into our quadratic, we get 4 squared, that's b squared, minus 4 times 1 times 4, that's a and c. And we get, when we do that, 16 squared, this also is 16. 16 minus 16 is 0. So when we get 0 out for the discriminant, we know that there's exactly one solution. So this 2, that was this one here, so this is in exactly one place. So that makes sense. This is actually a scaling this one right in the cell. This is that same formula that we just did. Let's skip ahead to when we get 2 solutions. So that's where it has to be a first place. So x squared plus 3x minus 10 equals 0. Also conveniently in similar form, we have a equals 1, b equals 3, and c is -10. Simply plug all of that in, we get b squared minus 4ac. So b is 3, so 3 squared minus
4 times 1 times negative 10. Here, the reason it's simple is not nice is because we have a negative times a negative, so just be careful. Positive 40, okay? And then we get 49 as our discriminant. So here, the number of solutions, because we have a positive number in our discriminant, it's going to give us 2 solutions, then that is what class to us actually. Alright, so the last thing we're going to do there is steps to finding the zero, or the solution, using the quadratic formula. So we'll run through the steps and then we'll keep a nice little list running on the side there. So first, we'll make sure that the equation is in standard form. So the examples that we just did had them all set in standard form. Sometimes that won't be the case. So once you've got it in standard form, we're going to find out what A, B, and C are. C for a bunch of reasons. And then we're going to fill in the quadratic formula. So put A in A, B, and C where they belong. You can clean the population user if you'd like. Number 4 is to simplify, so you do as much arithmetic as you can, and then finally you'll separate, you'll separate your plus and your minus, and you'll find your two, hopefully 2 zeros. Sometimes it'll be 0 zeros, and sometimes it'll be 1 0. So I've created this little list, we'll carry that along with us, so we can see where we're at in our process of finding zero. Let's start with this one. 2x squared minus 7x equals negative 1. Let's check our list here. Change into standard form. Well, this is not a standard form, and the standard form is ax squared plus bx plus c equals 0. We need to add 1 to both sides. We're going to change it into standard form, and I added 1 to both sides. And now we're in standard form. 2x squared minus 7x plus 1. We look at our list, and next thing we need to do is identify A, B, and C. So A here would be 2, B here would be negative 7, and C here would be 1. You can see the nice and color-coded phrase there. Okay. Next, and to step number 3 is to fill in the quadratic formula. So we had our A, B, and C, and we're going to plug those in from the previous slide. So negative 7 was our B, A was 2, and C was 1. Next is to simplify the quadratic formula. So essentially we're going to look here and do as much arithmetic as we can. So I have negative times a negative, I can make that positive. Under here I can square my negative 7. Under here I can do as multiplication, and I can do 2 times 2. Okay? So do negative times a negative, I square negative 7, and I do all this multiplication, negative 4 times 2 times 1, that's negative 8, and then 2 times 2 on the bottom. Okay? It's starting to look a lot less disastrous. Okay, next I can keep going. I can do 49 minus 6, 41. So 7 plus or minus the square root of 41 all over 4. Now here, we can take the square root and I've rounded this to just one decimal place. So the square root of 41 is something like 6.4. Now here is where we're going to be under our last step. We're going to find our zeros. We have to figure out what's going on with 7 plus or minus 6.4 over 4. So this is our answer so far, and then you can break this up into the 7 plus 6.4 over 4 component and the minus version. So you'll have the plus version, the 7 plus 6.4 over 4, and the minus version, 7 minus 6.4 over 4.
That's just pretty simple to find the zero, so we just do the addition and then divide. So 7 plus 6.4 is 13.4 divided by 4. That rounds to something like 3.4. Okay, we'll just stop at 1 decimal. That'll be good for right now. And then on this one, we do the subtraction on top, 7 minus 6.4. So notice it's the same expression, just there's a plus here and a minus there. So 7 minus 6.4 is 0.6. And divide that by 4, you get 0.15, or rounded, you get 0.2. So those are our 2 approximate solutions for our quadratic. Hopefully that makes some sense. Please let me know if you guys have questions. Good luck.